and it's a lovely little meter, and it's going to live on the bench. Hi folks, and welcome to another episode of The Art of Engineering. In today's episode, we are going to look at test equipment. So let's charge over to the test bench and have a look at some of the toys that I've had for a long time and some of the new arrivals that I'm very excited about. Let's go. Now, the first piece of test equipment that I'm going to show you is called a multimeter. I think most people will know what this is and they'll have seen these before. Now, multimeters have come a long way over the last few years. Once upon a time, you would have an analog meter, and those things are amazing. I'm hoping to get hold of one day. But look at that, ink all over my hand, disgusting. But what I want to do is just quickly show you that, the basic features of these things is that they will measure things like voltage, and both of these will do that, millivolts as well. We've also got things like frequency. Now, the frequency scale is quite useful. When I was building my mooncake transmitter, I could actually check to see if the oscillator was oscillating, which was great. We've also got transistor gain here, and these will also measure microamps, milliamps, and you can also get these things to measure capacitance as well. So there's a myriad of things that these meters are capable of doing depending on the type of meter you get. Now, the reason why I bought this one is because this one here, the center dial quite often plays up and it's not very accurate. And it has been able to do its job, but I have had moments where I've been a little bit untrusting of what it was telling me. So look, it will be my standby meter, but this little baby here, got it at J-Car the other day. Unfortunately, J-Car's across the road from my work, so I spend a lot of time and a lot of money in there. Anyway, that's the first piece of test equipment. As you can see here, just to show you the sort of thing you can do with it, we are going to turn on our switch mode supply here, which should be giving us about 13.8 volts if it's doing what it's supposed to. We stick our meter in there, and there you go, 13.95 volts, and probably a little bit high. But anyway, that's what it is telling me that supply is giving me, and it wouldn't surprise me if it's not perfectly accurate because it's a piece of junk. Nearly forgot. Could you please, if you've enjoyed this content, you're enjoying the videos, hit that like button, hit the subscribe button, and send me a nice comment below. Back to the video. Now, this magic, wonderful little box is called a component tester or a multi-function tester. You can buy these online. This one says multi-function tester TC1, and they recharge USB-C. And what you can do with this is, a lot of the time when I've got transistors, I can obviously look up the data sheet for a particular transistor, but sometimes you won't even know what transistor you're dealing with. And sometimes you won't know the pin out for it. And that can be very difficult. So what you can do with this little device is you can pop it in to these slots here, lock it down, and hit test. And it will tell you it's testing, and it tells you that's a bipolar junction transistor, NPN, and it gives you the pin out. It says that number 2 is the collector, and number 2 is the center pin. Number 1 is the emitter. So number 1 is this one on the left over here, and the other one is the base. So this is a really handy thing for pinouts. Now, obviously, you could use a multimeter, and there's ways of testing for that. But gee, this is so much quicker and so much more convenient. Thank you to my friend VK2NAP Chris for sending this my way. It can also do capacitance testing. This is let's have a look. This is a 10 microfarad capacitor. So it should say 10 microfarads when we plug it in, and it's got really gnarly leads on it. So we'll try and go, is it gone in? It hasn't gone in. Finally got it in there. Click it on. Testing, Capacitor, 9774 nanofarads, close enough to 10 microfarads. Even gives you an equivalent series resistance of 1 and a voltage loss of 0.2%. So that is a wonderful little piece of equipment that you can test capacitors on. This is a resistor. I'm not sure what value it is. Can't be bothered reading it. A lot of the time I can't even remember how to read 5-banders anymore because I just don't do it anymore. I used to know how to do it, but it's something that I don't actually do anymore because A, my eyesight's terrible, and B, I usually just grab a multimeter and do it with the multimeter. So we've got here, which is kind of a nice way of double checking that they're correct. This is telling me that this is a 996 kilo ohm. So I would say that's a 10 kilo ohm resistor, close enough with the tolerance. So we will pop this in. If it says 10 kilo ohms, we'll know that this little piece of marvelous technology is not lying to us. Click the button, testing, 997 ohms, giving you what pins it goes to and everything else. Amazing. So this is a wonderful thing to own. Like I said, saves you going to a data sheet to find pinouts, and just because it's such a cheap little thing to buy, I think this is something you should grab hold of when the opportunity avails itself. The multi-function tester. Now, we were able to test capacitors on our multimeter and resistance and lots of other things. One thing that we can't test is inductance. And quite often when you're winding toroids, they'll give you instructions on what former to use, how many turns, what gauge wire to use, everything else. But quite often you'll find yourself in a circumstance where you have a different former that'll meet the requirements but is a different size, or say you're winding a coil for an antenna, you've got a plastic former that's a slightly different diameter, and you're not sure how that's going to affect the actual inductance that's required. This is a godsend. You can actually plug this into the coil and work out what your inductance is. So I'm going to quickly find an inductor and we'll do a quick test with it. Now, this is a trifilar that I wound on a very, very bad toroid that was never going to do the job it was required to do. I'm not even sure how it was wound in the first place, but I'm just going to like plug into it randomly and we're going to see if it gives us a value of inductance. Plug it in. I've got these little alligator clip leads on it. They're very handy, especially when you're haven't got a free hand. And that is telling me that is 0.19 or 0.016 millihenries. So you can switch through the ranges. So it is not a very high value. On my power supply here, for the noise reduction, we've got a toroid as well. This one here. So, hey, I haven't got the power on, so I'm hoping I'm not gonna blast my meter. Let's have a look and see whether we can get a value. And there you have it, folks. That is 0.5 millihenries. So as you can see, this could be a very handy little piece of test equipment to have at your disposal when you are winding coils of any sort, the LC meter. This is probably the second thing I got. I used it when I was building antenna coils and whatnot. So this is a great thing to have. Now, another piece of equipment that I got quite early on was this VSWR meter. I've now got one sitting inside my antenna tuning unit, which I use most often. And I've also got in the Hermes Light, it's inbuilt SWR meter. So this is going to live on the test bench when I'm building gear to test power output and whatnot. It will do, it says here, it will do, God, I've forgotten my glasses. I'm going to need these. It'll do 430 to 1300 megs and 1.8 to 160 megs. And it's a lovely little meter, and it's going to live on the bench to allow me to test, like I said, power outputs from rigs and whatnot while we're at it. These were a game changer for me as well. When I was building the QCX Mini and other small rigs, trying to find holes for components and whatnot, not getting any younger, the vision isn't getting any better. and these were a game changer. So don't struggle, don't make things difficult for you. Get some form of magnification to make your life easier. Because if you're like me, you're not only follically challenged, you're also visually challenged. Now, this little marvel is the Nano VNA. A million videos online about this little thing, this little marvel. It's quite cheap to buy. You can get them for like sometimes less than $100. But look around online. This unit, mainly what I've been using it for is antenna analysis. So you can do a sweep across a frequency range and you can actually work out whether your antenna is resonant or not. But you can also use it to test for attenuation through a filter and sweep the filter to get an idea of the pass band, or if it's a low pass or a high pass filter, that it's actually passing the frequencies that it needs to. Once upon a time, this type of equipment, a VNA, a vector network analyzer, was a hugely expensive piece of equipment. I remember when I started out in ham radio when I was a novice back in the 80s, I had a good friend who was my mentor, and he actually lent me a grid dip oscillator and a signal generator. And if I wanted to test for resonance on my antenna, I had to like move the signal generator around until I saw a dip, and that would tell me whether I was getting closer or further away from the resonant frequency that I required. As for scanning across an entire band or across a whole range of frequencies to see whether a multi-band antenna met its requirements, that was stuff that only dreams were made of. So the stuff that you have at your disposal as a ham these days is amazing, and the technology that you have at your disposal is also awesome. So if you want to see how this is used, jump on the playlist, have a look at some of my antenna videos, and you will see a demonstration of this device, the Nano VNA. And this is a switch mode supply. I think it'll take me up to 12 amps maximum. And I bought this originally to power rigs. It was very, very dirty, I found out. And this is a Drew Diamond circuit for filtering. It's also got a filter that goes on the mains cable here. And it definitely cleaned it up, made it very acceptable as a power supply to power transceivers. But I was set on building my own linear supply, which I have done, like I said, in an old PC case using rewound microwave transformers. So that is the power supply I use to power stuff when I'm playing around on the bench. I would love a variable power supply to be sitting right here. But unfortunately, that is something that has to come along at another time. The fan blows smoke away from my face, so I'm not breathing cancer-causing stuff when I'm soldering. And of course, that is my Dick Smith temperature-controlled soldering iron that I have had since I was like 12 years old, and it is still going. I actually bought a new tip for it. They were very hard to come by, but I managed to find a couple online, so I grabbed both of those. While we're at this part of the bench, myriad of tools. They should be more organized than this, but they're not. Small screwdrivers, side cutters, pliers, all that sort of stuff. This is a lighter for heat shrink, and this is a breadboard. Now, you probably saw the video with this. This is a DDS VFO, but it's got an old school analog dial. Like I said, look in the playlist, you'll find this. It's a fantastic design from a Japanese ham, and a German ham has improved it. Amazing circuit, great fun to build. And this is what's known as a breadboard for prototyping. I've got a few of these lying around, and when I do a quick and dirty circuit, I can just chuck it onto this. Not a huge fan of these things. Quite often you get dodgy leads and dodgy parts of the board, etc., etc. I prefer to ugly build on a piece of Vero board or even a piece of circuit board. Seems to work better, but I have used these, and like I said, that's quite a complex circuit, and it worked fine on that prototyping board. So that's something that you might want to get down the track as well. You may or may not know what this is. This is a very, very heavy transformer. It's a microwave transformer. And if you've been watching my channel, you will know that I went through a really crazy phase where I was going out and finding junked microwave ovens and ripping the transformers out of them, and then knocking the high voltage coil out of it so I could rewind it as a high amp transformer for a DC supply at a lower voltage. Like I said in the video, not a safe thing to do if you don't know what you're doing, so I'm not advocating you do the same. But what ended up happening was when I was testing this out, I was told that the resting current for these things, because they're not very efficient transformers, is very, very high. It's around 3 amps or something. It's ridiculously high. And I thought when I started building my power supply, which is also in a video in the ham radio playlist below, that I was basically stuffed and I was going to have to either buy a large toroidal transformer, which was going to cost me a fortune to build my linear power supply, or I was going to have to try and find a junked one that was more appropriate to rewind. But after reading the God of Homebrew, praise be Drew Diamond VK3XU, I worked out that you could actually, or Drew told me that you could actually take 2 of these things and put them in series, and that would lower the magnetizing current to an acceptable level. And it did. It got me down to 200 milliamps instead of like 1.8 amps. It was not 3 amps. It was about nearly 2 amps. So 2 amps, way too high, running very, very hot. 200 milliamps. Actually, I got it down as low as 170, I think. I ended up building the supply. It's under my shack's bench and it powers the entire station, and it has been working a treat. So thank you, Drew, for that information. But while I was playing with these, I needed to know whether the magnetizing current was higher or lower. And unfortunately, AC currents don't usually happen on your multimeter. You can get multimeters with that function on them, but mine didn't have it on it. It's probably something electricians quite often have. So I was in a bit of a pickle. So what I ended up doing was I got myself a clamp current meter. And what you do with this is you put it over one of the wires that's feeding either the primary or the secondary, and it will actually detect the current. And if you want to see this being used, go to my playlist and look up the videos where I'm experimenting with the rewinding of those transformers, and you can actually get to see how this actually works. Because it was a real godsend in the end to confirm that my experiments were actually working, and that I was going to end up with a transformer that wasn't going to set my shack on fire. Now, this little marvel is the tiny spectrum analyzer. Spectrum analyzer is a massively expensive piece of equipment normally. This thing, I think I paid $150 for it. Don't quote me on that, but they're not hideously expensive. And once upon a time, people would dream of having a spectrum analyzer. This thing has a number of leads that it comes with, and it also comes with a little whip antenna as well. Now, I've used this to check to see if my rigs are clean or dirty. There's a video on the playlist about that. So I am hoping that when I transmit on my Hermes light here, you're going to see a little spike happening here. So let's key down. And as you can see, you've got a little peak there. And that is where I am transmitting into the dummy load. That is the spectrum analyzer. Getting really late, nearly past midnight. So that is the Tiny SA, a great entree into the world of spectrum analyzers. And for its price, mostly accurate enough for us hams. So once again, we live in amazing times where we have such amazing equipment at our disposal. Jesus, it's hot tonight in Sydney. We nearly forgot our field strength meter, care of Drew Diamond's book, Projects for the Radio Amateur. And what this thing does is it basically detects radio transmission. So if you wanted to see whether you've made improvements on antenna gain and whatnot, it gives you a rough idea what's going on. So, 70 centimeter, you can see there that that's going off the scale. You can zero with this part of the meter and then wind your sensitivity back until it's not destroying the meter, and you can see that it's sensitive to the polarization as well. A neat little thing just to sniff out RF and see whether things are stronger or weaker. Video on my channel. Last but definitely not least is this, a Handtech digital storage oscilloscope. Now, this just arrived in the post. I am super excited about this. Basically what this is it's a voltmeter, but in the time domain. That's just a fancy way of saying that you can see waveforms over time.
Birdie num num.
And if you're looking at a particular frequency, or you want to see how much amplitude you have in a signal voltage wise, or you want to check how clean or how dirty a signal is, this is a way of doing it. You can also trace signals through an RF circuit and find out where things are not happening, which is a great way of finding a fault as well. So I could do an unboxing of this, but gee, there's a lot of unboxings on YouTube, and I used to love watching them, and I still do sometimes to see what comes with a particular product. But in this instance, these will be shipped sometimes with 2 probes, sometimes with 1 probe. Usually they're only going to ship it with 1 probe, even if it's a 2-channel. So make sure you grab that extra probe. You might as well, when if you're paying for shipping. I don't think I even had to pay for shipping for this thing. I don't know how China does it. Don't know how they're doing it, but they're doing it. This thing arrived incredibly quickly as well. I usually wait a couple of months for stuff to come on a slow boat from China. This must have come via air because it was here in a couple of weeks. And it took me long to actually pick it up from the parcel guy up the road because he was just being very difficult about me signing it out. But we got it out in the end. So I will unpack this, stick it on the test bench, and I will set things up. Not how it's going to be in the end. I need to build some shelves here. I need to organize this a lot better, but I'm going to try and at least make it a form of organized so that I can get on with Project 160. Project 160 is the completion of a QCX Plus 160 meter rig and also an antenna. I have found this antenna online. I don't know if it's going to work or it's not going to work. It's a freaky antenna from old times, and it's something that the Russian military has used as well. And I'm just really excited about having a crack at building one. So I will probably do that video in 2 parts, the transmitter or transceiver part quickly, and then I will do another antenna video where I'm building this antenna. And yeah, it's a fascinating antenna. If it works even reasonably well, it'll be amazing. Now, I would love to give you a rundown on how good a scope this is and what's going on, but my experience with oscilloscopes happened in the 80s, and more recently I was looking at digital storage oscilloscopes at the labs I was doing at UTS when I was working my way through my first year and a half of engineering, and we did have a play with them, but I would by no means say that I am an expert. But as you can see here, we have I think it's a 510 kilohertz signal here. Now what's great about this scope is it also has a signal generator over here and 2 separate channels. What I need to do now is calibrate the probes and really get to know this scope. So early days, but I'm a very happy man to have this on the test bench. There is so much to learn and discover in this device, and the plan is to now get this bench sorted out so that it won't be exactly how it's going to be, but it's a work in progress like everything in here, and I'm hoping that this will get me out of the pickles that I find myself in with my homebrew equipment. Wow, you're still here. Thank you for sticking around right to the end of the video. I hope this video has inspired you to homebrew and to maybe go out and buy some pieces of test equipment. It certainly makes the whole homebrew journey a lot easier and a lot more interesting. I've got lots of exciting episodes coming up, so please, like I said earlier in the video, reach down, hit the like button, hit the subscribe button, and I shall see you in the next episode of The Art of Engineering 7.3.